Welcome to SolidCAM Professor on our series of Getting Started. I'm Sydney, your SolidCAM Professor, and in this lesson we'll be doing our second part of multi-sided machining. Now if we take a look at this part, you'll see that this can be done using indexial machining, multi-sided machining, using a 5-axis machine. If we take a look at our home position, you'll see that we have two MAC positions. Within each MAC, we have a set of different positions. In our first MAC, we have our first holding position that we will be doing. First one, second one, third, fourth, and fifth position we'd like to work on. And in our second MAC, we have one position to do the side, which has to be done in a different clamping fixture. Now, in my first operation, I like to just do a simple face mill of this top face over here. So I'll go into my first operation, which was done in MAC 1 position 2, the second position. If I open the operation, you'll note that my geometry is the boundary of the entire part itself. The tool that I will be using will be a 16 millimeter end mill. My levels starting from 10 millimeters above, going to my depth of 0, which is also a distance of 10 millimeters from the upper level. In my technology, I'll be using the hatch option. If I take a look at the simulation, and I'll use the option of Solid Verify. First of all, note that my stock is already with the V-groove at the bottom to be grabbed into my fixture. Now my tool will be coming down, going across, and machining the top of this part, as you see here. Note also it's machining it on the proper angle that I had to be done. If I want, I could go back into my hatch. I can change some of the options over here. For example, I can say, instead of going at 90 degrees, as you've seen it being done on the part, I can do automatic optimal angle. And I can say also over here, if I want to go out further, to go across, and I'll even change that, for example, for 25%, and have this go out at 110%. I can have also an overlap of less than 65%. If I want, I can have it also at 20%. And when I do that, you'll note that this time the tool is coming from the side and working its way back and forth that way. Those are the different options we have with this part using the face milling option for machining the top of this face. Now in my next operation, I've decided to do another face mill operation on this side over here. So again, as you can see, I've done that. And note that the tool path is going across this way on purpose because, remember, I am holding it apart from the bottom over here, and I don't want to work this way, possibly having a crash into the table itself. Now in my next operation, I will be again doing a face mill operation, but on this side over here, as you can see. Again, I've used the MAC 1, however this time position 4, the fourth position. And again, I'm going on the surface back and forth using T1 with the same technology as I've used before. Now in my next operation, I want to continue working on position 4, but mill out these steps over here. I've simply done that by doing a profile operation. Again, using my Mach 1 4 position. My geometries, as you see, are these elements on the edges over here. The tool, I'll still be using that 16 millimeter tool. My upper level, as you can see over there, and my lower level, my profile depth, being at the bottom of that step. And the technology that I'll be using will be a typical technology of both rough and finish, with my link of a tangent of 9 millimeters. If I were to simulate that, you'll see that the tool goes back and forth on both sides. And in my solid verify simulation, you'll see that my tool goes down, clears it, and then works on the other side. And it's all done now. Now in my next operation, I'd like to mill out this particular slot over here using the pocket machining option. Again, this time I'll be working in my Mach 1 position 2. And in my pocket operation, I'll be using my geometry that I've created, the outside border of the slot itself. I'll be using a 10 millimeter end mill. My levels, as you see it, upper level and my pocket depth up until that step over there. And in my technology area, I'll be using wall offset plus a floor offset, and I'll also be doing a finish cut. In my link area, I'll be going straight into my part using a helical motion, as seen here. And I will lead out with an arc. If I were to simulate, you'll see that the tool goes in helical fashion, then moves around and mills out the pocket. If I use solid verify, you'll see that I'll do it one step at a time. The tool goes down and then mills out the entire slot. Now in the next operation, I'll continue with the slot, but this time milling out the bottom slot that I have over there. In that particular case, obviously my geometry is the bottom slot itself, but my tool will be the same tool, but my levels are different. I have my upper level, my pocket depth is different, and in my technology area, I do not have a floor offset because I'll be going all the way through the part itself, but I do have a wall offset and finishing on the wall itself. Again, in my link area, I'll be using the helical approach. If I simulate that, you'll see the tool goes in. Again, in my solid verify simulation, going down through the part itself until the very end. Now in the next operation, I want to start working now on this area over here, and for that I'll be using Mach 1 position 5. If I were to do the top view, you'll see that we're working directly onto this particular hole over here. So again, I'll be using this time a pocket operation for this, and in my pocket operation you'll see that my geometry is the floor, is this circle that we have over here. My tool, 10 millimeter tool, levels, the appropriate levels that I need. Technology, again the same thing as I've done before when I had a floor at the bottom of 0.2 millimeters with a wall and floor offset. and again link ramping in with a helical and out with an arc. My simulation right down the middle, as we saw. Now, what's important to note with all these operations that I've done up until now, the important thing is that we have all the proper positions for each one of these operations, whether it be here, here, or whatever operation that we need. Now, I've continued on this Mach 1 position 5. In the next hole, just simply doing a drill. In this particular operation, I've used the drill, a center drill, a spot drill I should say. My levels, upper level, my drill depth is 0, and just using my diameter value of 9 for my spot drill. If I were to simulate this and use the Solid Verify simulation, you'll note that the tool goes down exactly to the level that it has to. And if I do my next operation, which is a regular drill, I'll just simulate it, basically using the same technology. When I drill through, you'll see that it drills exactly right into that hole to the exact size that I need. Now, in my last operation, I want to now mill this particular step that you see here. And since I was holding it before on this side, so this will actually be a separate clamping situation. So therefore I have Mach 2 now, and I'll be using Mach 2 position 1. Take the side view. As you can see, it'll be working flat to that surface over there. And I want to just simply clean this flat area up, and I'll be using my face mill technology. In this particular case, my geometry has been created from the face itself by simply clicking on the face and I get the entire boundary that I have over there. My tool again will be my 16mm tool, end mill, upper level, face depth according to the depth that I want to get to. Technology, again I'll be using the hatch technology. Let's just simply do a quick simulation. And as you can see, it works on that part. And let me just do now a quick simulation of the entire part using Solid Verify. First operation, cleaning that area. Second operation, third. As you notice, it goes back and forth according to the side that it's be working on. Same thing over there. Working on the hole that we see over there. The next hole. And finally, our next side. And basically now we've completely completed our part using our 5-axis multi-sided machining. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.